triangle ABC has given vertices. Graph a triangle and classify it by its sides. Then determine if it's a right triangle. So first we have to draw the graph of our triangle. So let's draw XY plane. X-axis and Y-axis. We have to choose the unit. And first point 8 has coordinates 5, -1. So we have 5, 1, 2, 3, 4, 5, and -1. So this is our point A. Point B has coordinates -4, 1. So we have -1, -2, -3, -4, and 1. So approximately is here. Point B. And point C is 3, 3. So this is approximately here. This is our point C. 3, 3. A has 5, -1. And B has coordinates -4, 1. So now we can connect these points. This is approximately here. So this is our triangle ABC. Next we have to classify it by its sides. So we have to find the distance between points. So let me remind formula for the distance between 2 points. For example, if it is x1, y1, x2, y2, distance between points A and B is equal square root of, and from first coordinates, first we have to subtract first coordinates, and because we have AB, so from B we have to subtract x A. So we have x2 minus x1 to second power plus, and now we have to subtract y coordinates and to second power raised. So this is equal. Now we will substitute x2, x1, y2, y1 by numbers. So we have -4 minus 5 to second power plus, and now we have to subtract the y coordinates. So we have 1 minus -1 to second power. So this is equal square root of -4, -5 is -9 to second power is 81 plus negative and negative give me positive, so we have 1 plus 1 is 2 to second power is 4. So this is equal square root of 85. Next, we can calculate this, or we can left like this, it doesn't matter. We have to check if we have the same, if we get the same numbers. Next, we will find the distance between points. We have AB, so now AC. This is equal square root of, and we will use the same formula. So now C is the last point, so we have to first subtract x coordinates. So we have 3 minus 5 to second power plus y coordinates, so 3 minus -1 to second power. So this is equal square root of 3 minus 5 is 2 to second, -2 to second power is 4 plus 3, and we have negative give me positive, so we have 4 to second power is 16. So this is square root of 20. And now we have to find distance between points B, C. So we have B, C is equal. We will use the same formula. First we have to subtract x coordinates. So we have 3 minus negative 4 to second power plus 3 minus 1 to second power. So this is equal square root of 3 and negative give me positive. So we have 3 plus 4 is 7. 7 to second power is 49 plus 3 minus 1 is 2. 2 to second power is 4. So we have square root of 53. We see that we got different values. So every side is different. So our triangle is scalene triangle because every side is different. We don't have congruent sides. So we have scalene triangle. Next, we have to check if our triangle is right triangle. From our graph, we see that the bigger angle is C. To check if it is right angle, we will find the slope first of CB segment. Let me remind you formula. First, in numerator we have to subtract y coordinates, and in denominator we have to subtract x coordinates. So this is equal, b is last, so we will have 1 minus 3 over negative 4 minus 3. So this is equal negative 2 over negative 7. So negative and negative give me positive, so we have 2 over 7. And next we have to find the slope of CA segment. So we have to use the same formula. First we will subtract y coordinates in denominator, 8 is last, so we have negative 1 minus 3 over x coordinates now 5 minus 3. So this is equal negative 4 over 5 minus 3 is 2. So we have negative 2. So now the product of the slopes is 2 over 7 times negative 2, this is negative 4 over 7, is different than negative 1. So for sure our C angle is not right angle. Because angle C is not right angle, it means that our triangle is not right triangle. You can check if you don't believe me that this angle is not right angle and angle A is not right angle too. You can use the same formula. So it is not right triangle. This is my solution.